is a pretty important component in eutrophication, and we have very low dilution in the arid west. So we are committed to reducing our phosphorus as much as possible at the treatment facilities. Starting next year, we have to meet a permit limit for phosphorus of 1 milligram per liter on a median basis. And we chose biological phosphorus removal as a sustainable alternative for meeting that objective. We started piloting biological phosphorus removal in 2011, and following that we saw a lot of difficulties and challenges, including a loss of dewatterability of our biosolids, a recycle loop of phosphorus from the centrate that infiltrated the secondary treatment process, as well as pretty crippling struvite in all of our pipes and equipment and digesters.
So this is an example of some of the maintenance nightmares that we've had with the phosphorus accumulation in the digesters, in the pipes, in the formation of struvite. This is a chunk that we pulled out of the digester Admiral area. This is pretty much cement and is very difficult to move out of the pipes. With the open pipe after cleaning, we could get like 1,300 gallons a minute through the pipe. And when we started getting these restrictions, it could go as low as 400 or 500.
When we recognized that we had an issue that we needed to solve in our side stream as far as phosphorus sequestration needs, we did a pretty detailed evaluation on our technology alternatives. We pilot tested the MagPrex process and found that we got very consistent conversion and sequestration, thereby eliminating kind of that recycle loop. We also, during the pilot, paired it with a pilot centrifuge and saw that the detrimental impacts to dewatterability that we'd recognized full scale could be mitigated, increasing our total solids and reducing our polymer consumption by up to 25%.
The MagPrex system is a phosphorus removal system. It removes orthophosphate, soluble phosphorus, which is released in the anaerobic digestion process, right after the anaerobic digester and before dewatering. It's a very simple system. It's essentially a special fluidized bed reactor. We have no special equipment. Any operator will be able to operate and maintain the system.
The MagPrex process came online in November of 2020, and since it's been online, our plant has achieved very low effluent limits of total phosphorus. We have a current median for 2021 of 0.4 milligrams per liter, when our permit compliance limit is 1 milligram per liter.
Another benefit that we're seeing is reduction in polymer demand, which is used as a dewatering aid for our dewatering process. So we're seeing a reduction of about 25%, and this is saving us about $500,000 annually in chemical costs, which is a pretty substantial dollar amount. The system is very simple to operate. It's very hands-off. Our operators are able to control it directly from the control room and kind of see the immediate performance of it as well.
It's just been going in and checking in, monitoring. A few resets on the pumps, a few resets on the blowers when we have power outages, but for the most part it is pretty hands-off as far as operations go. It's more of a monitoring.
We have eliminated struvite production downstream of the MagPrex process. So that saves a lot of man hours as far as labor for jetting and taking down pipes and pumps.
Before the MagPrex unit went in, we were jetting almost every week. What we are finding out, there is still some formations in there, but what is in there seems to be much easier to remove now. So it's more just a maintenance issue now than it is a nightmare.
One of the benefits of MagPrex is the improvements that it has on the dewatterability of sludge. We could potentially eliminate ferric usage entirely. It's important to eliminate ferric usage for dewatering because every chemical that we add is going to ultimately make its way to the final effluent.
Because we are in the arid west, we have to be particularly careful in protecting our downstream source waters. And so we are very thoughtful about all of the chemicals we add and our total nutrients that we are discharging into our river, which winds up as the intake of somebody else's drinking water plant. We're very satisfied with the performance of biological phosphorus removal and attribute that to the reduction of phosphorus in the centrate being returned to the process.